So this video is about books. And before you click off, I know what you're thinking. Nobody in tech reads books anymore. You've got ChatGPT, you've got YouTube, you've got 100 different courses. Why would you sit down with a book? But that's exactly why the people who do are pulling ahead. And in this video, I'm going to show you the exact books that helped me get to where I am as an AI engineer. The first book we're going to look at is Python for Data Analysis, Data Wrangling with Pandas, NumPy, and Jupyter Notebook. Right. So this is from Wes McKinney. I find this book is very, very useful and one of the most foundational ones you need if you're going to be working as an AI engineer, actually working with practical examples and not just doing theory. Right now is at the third edition at the time of the recording of this video. But why this is very important is the fact that you're using the tech stack, that it teaches you how to do it. Other books that when I started learning in the past, assumed you knew how to do these things and didn't teach you at all. With this, they're making sure that you're actually working with these tech stack, which is common these days for AI engineering, data engineering, and all that manipulation. This is a common tech stack you see in paper, data wrangling right here. So NumPy is the numerical data, so you can crunch big numbers. Pandas is basically a layer on top of NumPy where you're allowed to work with Excel sheets or CVS files or CSV files, comma separated value files. And then Jupyter is a way to use what's called literate programming, where you're pretty much the explanation and the code is in one place so you understand what's happening and can use it to explain or even test out things, ideas before you actually code it into the final product. The next book I recommend is Learning the Pandas Library, Python Tools for Data Munging, Analysis, and Visualization. Basically, it's trending on book 12. That's what it's saying right here. Well, this is a Kindle edition here. But why I recommend this book is because, again, when I started learning the whole tech stack of data engineering, data manipulation, and then AI and ML, all the papers, especially earlier on, they were using either you code it yourself or they start using NumPy and then Pandas, and they never explained it. And even books that did use it only touch upon it a little bit. But when you start manipulating Jupyter Notebooks, there's a lot more intricate functions that are Pandas only, and it only goes deep, so deep. Whereas I find this book was like one of the few books that I actually found that allowed me to understand Pandas and all the other functions that the other books didn't cover. Because when you start working with your own data, you're going to find specific things, and it's hard to read the library or the documentation when you don't know what you're looking for. This book, I would say, was really, really helpful to understand what Pandas could do. And then when I went back and do things with NumPy, Pandas, Matplotlib, and Jupyter Notebooks, or now Jupyter Labs, it made a lot of sense. And I could keep those Jupyter Notebooks or Jupyter Labs to see how to manipulate certain data using Pandas. And this book was very, very helpful for that. The next book I would actually recommend is Data Science from Scratch, First Principles with Python. So you might be wondering, okay, well, if you have the other books that are teaching you NumPy, Pandas, and Matplotlib and Jupyter Notebooks, why would you need to learn it from scratch? Well, the thing is about that is that the tool sets, they'll show you examples of how to use the tools and how to use the functions from those libraries to make it work. But the thing is, why I think this is very important is because if you're doing it from scratch, you understand the principles itself behind the code. And then when you basically use the shortcuts from the libraries where you don't have to code out everything from yourself, you at least understand the parameters, why you're using it. So I find this is very helpful to understand it because at the end of the day, when you start doing AI engineering at the end, you're not going to code out these algorithms from scratch yourself, but you need to understand them. So understand how to use the models together, how to change the parameters, and doing this will help you understand them much better. The next book here is Python for Data Engineering. So you can build scalable pipelines, ETL systems, and automate data workflows. So why I think this is very important, because when you first learn data engineering, data manipulation, AI, ML, you're most likely going to learn more from the academic, from the theory point of view, and you're going to do probably toy projects just to get the understanding from it. However, to actually make real projects, you need to actually include data engineering as well, or just basically software engineering and designs and IT in general, right? Just build systems. And this book allows you to do that. Now, the thing is about this, to be honest with you, I would probably return back to this because this is more like software engineering, developer techniques that I would say you learn the other books on Python and NumPy and also Matplotlib and Pandas, and then build some models, get some ideas how projects will work. And once you know how to do that, then you will come back to this how to make this scalable, how to actually interact with it to actually build this within a real company solution. Because if you start off with this and you haven't actually built anything yet, going through all this stuff will probably be it'll be hard to understand if it's out of context. Whereas I would say if you start building projects and then you start trying to build them in a real world environment, and then you start seeing the limitations, a book like this will make a lot more sense because like, oh, that's how you take this model and scale it up and put it into, for example, they show you CI CD, which is like continuous integration, continuous development, how to connect to APIs and how to go to like AWS and the Google Cloud. I wouldn't worry about this stuff right off the bat, but once you get to that point and doing testing and documentation, reproducibility, that is actually the engineering part and software development. That is actually deploying it in companies or in real solutions. That's where I would say you'll come back and refine your skills at this point. So let's move on to the next book I would recommend you read and that I read that I feel is very important. Now, the thing is, right now, the term AI is pretty much, the buzzword that's going around. And when we refer to AI, most people are referring to like neural networks or deep networks, deep neural nets. However, the term itself has been used, or the approach is a lot more broad and has been used for years, for decades prior to neural networks. Neural networks just happen to be one of the sub categories of it. Now, this book, Artificial Intelligence, A Modern Approach from Pearson series, this book is actually what NASA used for training their engineers for this. And this fourth edition now has AI and like ML solutions or approaches within it. But prior to them, the books I read, the earlier editions I read, use more classical approaches, just algorithms, as opposed to neural networks itself. And the thing is about it, why I still say this is important. One, they updated to now include ML and AI as well. So it's up to date with the newer techniques. But also, a lot of solutions work with classical algorithms first. And in fact, when you approach a new problem, you want to do a benchmark or baseline by using known algorithms and see how well it does. And actually, a lot of cases it works. And if you could just go in, and another thing about these, a lot of the techniques in here might already be in scikit-learn, which that's a package that's within Python. So you don't even have to write out the code. Here you understand the concept, but then you just go into scikit-learn, bring in the package, and just like a line or two of code, you start using it. But to understand what it does and what it's trying to do, you need to understand this book. And now with the fourth edition, it would actually take a more modern approach as well and show you how to do AI and ML solutions as well. So that one is, as they say, the most comprehensive, up-to-date version. I would say this is a must-have. Again, if NASA is using it and they're sending people to space, I would say it's pretty important it's pretty well known. It's actually battle tested, I would say, in the field. This next book, Grokking Machine Learning, is one of the books I highly recommend for you to start learning AI, machine learning specifically. Again, AI is the broad category. Then there's like machine learning, and then under that there's like deep learning. Now, why I recommend this book specifically is because it's designed specifically to work with the standard Python code, just standard library, not NumPy or basically not depending on specialized libraries specifically for AI. So you're actually building out the code, and it's just using high school level math so you understand it, and it's meant to be basically it'd be like entry level. So people who have no background experience, you don't have to have special knowledge. So even younger people in high school can start learning ML. So kids could start learning it at an earlier age. You don't have to be at a postgraduate PhD level to start understanding how this actually works and actually implement this. This is really important, I find, because once you understand the concepts, then you could go into more of like the de facto books that are known, but they're written for the PhD level. So a common person without specialized knowledge wouldn't be able to understand or pick up what is happening because they're not trying to design the language so anyone could understand. They're designing for academics. but the concept itself can be explained to anyone pretty much. And this book is taking that approach. So you understand it and you can code it and you get it and you're like, oh, this is how it works. So when you do look at more complicated books or resources, you understand what's actually happening. That's why I would say if you're starting out, start with this book to understand machine learning and to actually code it in a practical way. Again, at the end, when you start using AI engineering, you're not going to be coding it at all because models already exist. But this makes you understand it and why it's happening and how the math works before you move on. Now, the next book here, Grokking Deep Learning, this looks very similar to the other one I was recommending or that I read, and how it impacted me as well. Like so, grokking machine learning. So the things about machine learning is it's under the category of AI because AI is pretty broad in terms of the definition of it, and then machine learning doesn't necessarily mean neural networks. It can use classical algorithms, like I mentioned in the book, that artificial intelligence, a modern approach where NASA was using. That's what AI was before, and it still is. But like now, when we say AI, we're thinking neural networks. Deep learning specifically does use neural networks, and the term deep learning is kind of like loosely based or like the buzzword that a neural network that has more than two layers of neurons is considered deep. Nowadays, it's probably a lot more, but that was kind of like classified what deep learning was, or the term came about like 10 years ago. And again, this is a very useful book just because the main thing, again, from similar to the other grokking deep learning, is meant for people that don't have specialized background. You could just have understand high school math and understand the basics of Python, and you'll be able to build neural networks from scratch, understand how they work, what is a neural network, what are the weights, what are the architectures, and you do it from scratch. In this case, they are using Python, but because Python is kind of just pure general purpose, Python would be slow for calculating neural networks. You will actually be using NumPy as well. So you'll learn how to use that just to speed things up. And again, you can use just pure Python and not NumPy. Well, again, NumPy is a package under Python, but the backend is C++, so it just makes the calculations a lot faster. And trust me, I've done this before where I build neural networks purely with Python. It takes a lot longer, significantly longer. So NumPy, you're just using that to speed up. You're still doing the same math, but it's just a more efficient way of doing that. But this is a great way, this book, I highly recommend to understand deep learning. So when you start going into scikit-learn, which is more like not as deep learning, but like PyTorch or TensorFlow, you understand what's happening. The next book I've read that I find is very helpful in my opinion on this as well. This is a very helpful book, but again, the hands-on machine learning with scikit-learn, Keras, and TensorFlow, it's really helpful because you start using machine learning, but you're using libraries or frameworks such as scikit-learn, which also has a lot of the classical algorithms in there for AI. And then Keras and TensorFlow, those are frameworks. They were around before PyTorch. PyTorch is kind of like now the standard, but I still think this is very helpful because you're still learning the frameworks and you still work the same way. It's kind of like if you learn how to use Microsoft Word and then now you're working with Google Docs, right? You understand the concepts and you know in general what you're trying to do, but in each one is working a little differently. But in practice, you're going to be actually using the frameworks as opposed to the other books like Grokking Machine Learning or Grokking Deep Learning. You do that because you're trying to understand how neural networks work. So when you work with this stuff, where you just bring in the libraries and you're just setting parameters, you understand what those parameters mean. But in real practice, you'll probably be working with these things. And again, when you're working as an AI engineer, you wouldn't be actually building these models out of this or PyTorch. Those will already be built. But understanding how those framework works, because that's where they were trained on before they're optimized, it will help you understand how to work not just with deep neural networks or machine learning algorithms. You also understand how those are implemented in frameworks in general, and then how you could implement them with data engineering or basically data engineering or software engineering in general, where you could use APIs and deploy them to CI/CD. This is helping you understand how that works. So I would definitely recommend this. And this is the second edition. Now it's updated with TensorFlow 2, just to let you know. TensorFlow earlier on, there's scikit-learn that, and then after like Keras, and TensorFlow was kind of best of Google's framework of building out neural networks, and it was kind of like used for a while until Meta, or Facebook, or Meta, Facebook, I guess at the time, uh, brought out PyTorch, and the difference is just the way TensorFlow worked. You kind of had to like set a state and like execute it, whereas PyTorch started working more Pythonically, or the way Python would work, or how you would expect it. Then they updated to use TensorFlow 2 to work similar to like how Python, or very similar to how PyTorch works. So using this will help out because, again, like I said, PyTorch is still right now the de facto, or that the industry standard. If you're reading a paper, if you're actually doing that, they're using PyTorch now. But TensorFlow is very similar to it, so it makes it easier that if you learn how to do it in TensorFlow, it's easier to translate it into PyTorch. Similar to, again, if you wrote something in Microsoft Word, now I have to do it in Google Docs. You'll find that you'll understand a lot of the concepts. You just have to find out where the buttons are, or what are the functions, or how they say it from one framework to the other. Next up of this book here is Deep Learning, Adaptive Computation, and Machine Learning series. Now, this book is pretty much kind of like in the academic world, one of the de facto books to understand. Again, it's written by like, Ian Goodfellow and like Yoshia Bengio. They created at the time, the godfather of like AI here. And then Ian Goodfellow created like adversarial networks, or GAN's network, which was revolutionary at the time for it. So this, however, my opinion on this is that at the time, if you were building neural networks, this is definitely one of the books kind of like, it has a broad range of different topics of deep learning and covering mathematical and conceptual background, but it's mainly learning the concepts and the techniques behind it. This is helpful if you're a researcher, because this is at like a graduate, postgraduate level, meaning like master's, PhD level, which means that they expect you to be already a master of the space already. You already know how to code. You already know a lot of these algorithms, and it's a lot of academic jargon. And the thing is about this is, unless you're going to be a researcher, I probably wouldn't recommend this, unless it's more of like a resource as a point of reference if you try to understand a concept at a deeper level. In practice, I don't think you need to know it at a graduate level or postgraduate level. And it's going to be, even reading it'll be very complicated unless you have very deep math and experience in actually coding these things and working in projects in research for that. So honestly, I wouldn't say, if you're going to be an AI engineer where you're actually implementing and practically doing things, using the other books that I mentioned before, like Grokking Machine Learning and Grokking Deep Learning, to get a general idea of how the concepts work and actually hands-on work with it. And then using other books to learn NumPy, Pandas to manipulate data. And then after, the other books for TensorFlow or TensorFlow 2, which you translate to PyTorch, you understand in a practical way what's working, how it comes together, and you don't need to actually go and code this yourself. Take that and go this deep, unless you want it as a point of reference, and that's your interest. But I wouldn't do that. I'll think of it like this: it's, if you know how to build a computer, if you're like a technician, you know how to build a computer, in the sense that a graphics card is already built. You go in and buy the latest one. You go and buy like the hard drives, and you know how to put together. You understand the concepts, how it would work, and you just need a computer to work. That's what I would say as a engineer. What you want to be doing. You don't need to actually know how to build the graphics card from scratch, unless you're going to do that. That's similar to what I'm saying here. Unless you're going to build the model from scratch, this is just good for a point of reference, but not necessarily to learn to be an AI engineer. It's not required. Now, I want to recommend these books if you're taking a step back. If you've never coded before, you don't know Python. And the reason why I'm talking about Python, because Python, specifically version 3 nowadays, is the de facto language used in as a common thread to do AI engineering and data manipulation and data engineering and whatnot. So if you don't know that, I would recommend the book I read that I find was the most helpful, because I learned Python. I learned other languages first, but on actual projects, I kind of picked up Python and I looked it up. So this book was very helpful. Originally, it was from like a blog that was called Module of the Week. And basically, it's just the standard library that's in Python, but instead of reading the documentation, it actually explains how to use it, how to implement it, and give you an example that I found was super helpful. And this was probably the best resource that I found to help me actually understand how Python works. And I still use it if I try to use a library, like how do I take a file and copy it from one folder to another? I would look it up in here. I find it's a lot easier. So I highly recommend that. I find this was probably the biggest impact in terms of getting something quickly, working in Python, straight to the point, and so I could just move on. The next book I would recommend just to learn Python are just the awesome tricks about Buffet. It's pretty much kind of like a bunch of tricks that you should know that helps you out a lot in Python. So with the Python tricks of the book, so speak a buffet of awesome Python features. And as you know, here is pretty much if you're wondering like which lesser known parts of Python you should know about, this is a roadmap of the book you should know. And a lot of it you'll be like, oh, this is very helpful for my day-to-day use. And I find there's a lot of tricks that will save you in a lot of cases that you could reuse over and over again. So I highly recommend this book for that. Basically, again, you're not necessarily trying to be an expert Python coder. You need it to actually make it work, and having kind of like recipes and tricks that work out of the box, you solve it and you can move on. Again, continuing with books that I would recommend that I thought was very helpful when you're starting to learn Python, because again, I didn't, when I learned Python, I didn't take a formal course. I was already working on real projects, and Python had to be the language. So I couldn't just take theory. And I found this book very helpful, Automate the Boring Stuff with Python. It's a practical programming for total beginners. You'll actually see just common things that normal people would do in and like their day to day, especially if you want to say you work in, let's say, office work, and you just do the simple things of like copying files from one place to the other. Going through here, you're like, oh, I could see how Python is super helpful in this case. And it translates directly because you're actually working on real problems that you probably face day to day already, or just working on the computer that Python could solve. And it will make you understand Python a lot better. That combined with the other books that I mentioned before, of like the Module of the Week book, or Python by example, the book version of it. The Python of the Week was a blog. It shows you how to use the library itself, and it was going to be more like a reference point, and also the tricks on top of that. This gets you up and fast working with Python, because again, your main goal is not to be necessarily a Python guru and know every little thing. You want to know enough to actually be useful, so you can start implementing and working with Python to talk to it and use all the tools as an AI engineer. Now, this book, O'Reilly's Architecture Patterns with Python, which is enabling test-driven development, domain-driven design, and event-driven microservices, is extremely powerful, extremely important. However, one thing I would say with this is that I wouldn't, on your path to learning Python, I would learn kind of like the Automate the Boring Stuff Python book, so you understand how Python works in general, and then be familiar with the Python standard library by example, and you could use the website for that as well. It's a blog. All the chapters are in there as well for free. And basically use that instead of the documentation to look up how to use something really quickly and to get you up and running to use Python to move forward. Now, this is very important. It's more of a higher level. And in fact, when you get to the professional level, these are the things you want to develop as a software engineer, as a software developer, enabling test-driven development. That is like TDD. Basically, it's a way of certain patterns, a certain way of approaching things to actually make usable code in production. And now, again, the main thing is that it's in production. So if you're like actually working on a real project, working with a real company, when you start out, you're not doing any of this stuff. So you're optimizing to make it scalable, but you haven't encountered anything yet. So I feel that it's early when you start learning Python, learn how everything works. And then once you start working real projects and get that working, and then you start working to deploy that and get it on the cloud and working with other people on it, then this book's come into play for it. So it's an important book, yes, but I think there's an order of operations with it. You would come back to this once you have a little more experience to actually design some things. This was going to separate you from everyone else as an actual professional. But starting off with it, I would think it would be kind of overwhelming because you don't have a point of reference yet. because you haven't built any real world things at the start. Once you have, and then come back and like, oh, this is a better way to design it. Now, stepping back even further, so we started off with, data books and the frameworks, the tech stack you would use for AI engineering or data engineering, and then basically how to use Python. And but one level below that as well is just the mathematics in general. And these books, I would say, for example, Mathematics for Machine Learning, I would take this as more of a point of reference if you want to understand the actual math behind it. But again, a lot of I wouldn't say it's necessary if you're trying to be an AI engineer. I think doing the books that I mentioned earlier, grokking machine learning and grokking deep learning, you'll understand enough of the math to get by, to make it work, and also how the architectures work. But for reference, if again, if unless you're trying to be a researcher, which then these things are going to be a lot more important because you have to know these things inside out. But if for I would say, like, when back then I was building models, but nowadays I wouldn't even say it's not necessary. But having these books, if you ever want a point of reference, is okay, why is this algorithm or the math, how does that work? At least you have a book like this to look up and understand it. If you would, I wouldn't say it's necessary nowadays to be an AI engineer to actually implement the models, because the models already have this solved. You just connected them to make it work. Other books I would recommend for the math part, because in AI engineering, basically, or machine learning, deep learning, the math that's usually involved is linear algebra. Well, knowing basically high school math, and then linear algebra, and then statistics, and like calculus. So if you want to understand the statistic parts of it, this is just pure statistics in general, not specifically just AI. But again, data analysis has been around. I would say if you want to understand those algorithms itself, think stats. Again, I don't think it's necessary to actually use because the models already have these implemented. It's more for your background that you're like, okay, well, how does the math or the statistics work for this? And if you want to understand those concepts, I would have a book like this for a point of reference. I don't think it's necessary to read this to its completion and understand every single thing of it to actually be an AI engineer and actually build it. And again, doing the books like Grokking Machine Learning and Grokking Deep Learning, you'll learn enough of the concept of it to be useful for your day-to-day of it. This is just going deeper if you were like, okay, well, I really want to understand, but that's more for your understanding part of it. So and that's why I have this book covered. If you ever need a point of reference to look up something, understanding it and look at this book will be very helpful. And just continuing on for statistics, because again, AI ML models, you basically, data mining or data engineering or data manipulation prior to the whole deep learning and neural networks. And again, going back to the books that I've mentioned before, like AI, A Modern Approach, which is what's used from NASA, heavily relies on statistical models and those algorithms. So this is just another book. Again, if you ever want as a point of reference to understand those statistical models and the elements of statistical learning. So again, I don't think you need to read it to become an AI engineer. But again, if this is for your library, or at any point, if you need to understand something a little deeper than what you learn on like grokking machine learning or grokking deep learning, this is another point of reference for that use case. Think of it as like, having a dictionary is helpful to look at words. No one will tell you sit down and read every single word in the dictionary to know the language. But if you ever need to understand something, you can look it up. That's why I recommend these type of books. So you have a point of reference that if you need to go deeper into something on statistics, here's a resource that you can use. Back to, again, points of reference. If I mentioned before that AI has been around for a while prior to the associated with deep learning. So if you're going to be using learning books, learning techniques from, let's say, AI modern, the modern approach of that again, NASA uses, and you'll see that you'll hear this term a lot, like Bayesian data analysis. So to have a point of reference of how that works, I would recommend this book, Bayesian Data Analysis, third edition, for it. And again, it's a point of reference to understand the concept of it. So you'll see once you start doing, if you start doing the classical AI algorithms, you'll understand much better what this is as a point of reference. Again, I wouldn't sit down and read this book from cover to cover. It's more of, okay, there's a certain concept I don't understand because what are the other books kind of like gloss over it, and I need to understand a little better. This will be a point of reference for that. Now, this book I read, AI Engineering, Building Application with foundation models, and I saw I got a lot of great reviews. And honestly, I wouldn't necessarily recommend this book because I'm not even sure who the target audience is for it. Because if you're already working as an AI engineer, this is kind of like broad strokes and it doesn't actually show you how to build anything. And I'm not trying to bash it or downplay it on it. Like what it's saying in there is correct, but I think it's very similar to as if, let's say, a surgeon, a doctor, like a surgeon, came and gave like a 1 hour seminar and explained everything they did in a high level. So it gives you an idea what it is, but to claim that, okay, after doing this one seminar, you're going to be a surgeon, that I don't agree with. And I feel that's kind of what this book felt like. So building applications with foundation models, it could be kind of misleading that, okay, once you read this, you're able to build applications of it. I would say if you've never done anything before, but even not even a complete beginner, I think you still have to have some example, some experience with in tech to understand high level what to look for. I would say this is similar to as if I read a syllabus for a course so pretty much it can tell you high level, like, oh, these are the topics I need to know. But just from reading the syllabus, you can't actually do anything. That's what I felt reading this book. And so in that sense, it can give you a direction of what to look into. It's more of an intro, but don't expect it to come and read this and you're like, okay, I know how to do something with it. There's nothing practical out of it. And so a lot of things I would say is kind of they gloss over. So really, really quickly. So you still have to look it up. But if you read the other books, or to actually understand this, I would say you would probably have to read the other books. But if you read the other books, you probably don't need this. I find this very similar. I'll give an example. When I was started to learn coding through class, going to school, the way the professors who were teaching it were already experts in the field. So they'll come in and they'll explain a concept in one sentence and expect you to be an expert in it. And then afterwards, they just use the concept as if you understand everything. But I'm still stuck on like, what does that mean? So I'm lost for the rest of the lesson. So what I had to do was I had to go in and study beforehand to understand the concept, study for hours. So when I got into class, I understood what he said when he explained that one sentence and used it afterwards in for the rest of the lesson. Now the thing is, I'm like, okay, great, now I understand it. But at the same time, because I went back and understood what all that meant, I didn't need to be there because he's just explaining and showing what I had to go study so I could understand and follow in the lesson. That's kind of how I felt reading this book, where if you already do AI engineering, going through here, like, okay, well, I know these things already. But I felt that if you haven't done this before, what they're saying is not wrong, but if you're going in and for the first time and hearing it, you're going to be lost for the rest of it. And you have to go back and read and understand those topics. But if you understand those topics, you don't necessarily need this, right? Because they don't actually show you how to do it. That's why I say it's very similar to a syllabus. And I'm not trying to downplay it because a lot of people say it was very helpful. If you actually read the reviews on it, I think like some of the people were even mentioning some along the lines of what I was mentioning, that it gives you a good sense that if you already have some information or have some experience with tech, like yeah, right here, like for example, I kind of agree with this. Very detailed and well explained. Again, I don't think it's wrong. I'm not saying what they're saying is incorrect, but anyone with basic knowledge of computer science can read this book, right? So if you already have tech and you have some idea of what it is, it can I don't know this part because the thing is when they made this example, they said they just read the first chapter, and when I read the first chapter, I kind of agree with that. But when you go to the other chapters, like when they talk about like RAG and also so what is some of the topics they mentioned? The the open mind, yeah, AI as a judge approach. Some of those things could be helpful, but when they start going into detail or start talking about papers, if you're completely new and you've never read a paper before, you're not going to understand what that means. So that's what I'm saying. I'm not sure who the exact audience is. So, and to understand, and like I mentioned, all those other books I mentioned to read, once you understand that, then this will make a lot more sense. But if you know those other things, and I, like, again, if you're already doing AI engineering by the time you're doing all those other things, I don't know how helpful this is to you. So that's my opinion of it. Again, I'm not trying to like bash it because other people thought it was helpful for them. Just understand that you're not actually, you could read the reviews for yourself. You're not actually just read this book and be able to build out of the box. I really feel like this is a synopsis of the topic of AI engineering, of things you need to know. But for the price point of that, I'm not sure if if it's helpful to justify that. AI is reshaping development. The jobs are evolving. The books are like a secret weapon to give you that edge. The developers who adapt are making 200K plus. So if you want the exact steps to make that move, the skills, the positioning, the path to 200K plus AI roles, then check out the links in the description.